Hi, this is Robin, your Nursing Success Mentor. We're doing a question from your practice problems in dimensional analysis, formula, and ratio and proportion. It's number 15, and let's get started. For formula, let's go ahead and decide which formula we can use here. I'll read the question. The order is for oxytocin, 7 milliunits IV per minute. Oxytocin 20 units is added to 1,000 ml of intravenous solution. How many milliliters per hour will you set the IV pump at? So we're looking for milliliters per hour. What kind of question is this? Is this a fluid rate question, fluid delivery, amount of fluid, or is it a medication ordered per amount of time? And it is actually a dosage calc medication question. The order is 7 milliunits per minute. So that clues us that we're going to need to use the formula for basic dosage calculation. It's going to be just altered a little bit though, with the tag of amount of medicine per hour, and you'll see. So this is the formula on the left, the basic formula from our book and Calculate with Confidence, and the dosage desired over dosage on hand times the quantity equals, in this case it's ml, but it's, it could be tablets, capsules. For this, we are just adding the tag of per hour. So the dosage ordered per hour over what's on hand times the quantity. That doesn't change, but it does give us milliliters per hour. And you can see this starting on page 576 in your book. So for this problem, we have to do two things first. Step one, we've got to calculate the dose per hour. They've given us 7 milliunits per minute as the order, but to put it in the formula, we're going to calculate per hour. So we just multiply it by 60 minutes in an hour. We get 420 milliunits per hour is our order. Next thing, we've got to get the ordered and available strength in the same units. We've got 20 units for the available. We've got millunits for the order. You can go either way. Our book likes to go one way, but we can go either way. And we're going to go to the ordered strength. So we're going to take our 20 units that are in the 1,000 mLs, and we're going to multiply by 1,000. Because there's 1,000 millunits per 1 unit. And so that gives us 20,000 units now in 1,000 mLs as our new available strength, our new available drug on hand, essentially. It's just a big drug on hand. So let's do step 3 and solve. Dosage desired is the 420 millunits per hour. Put that little tag there. That gives you the tag over here. In 20,000 millunits, which is in 1,000 mLs, and that gives you your 21 mLs per hour. That's what you'll set the pump at to deliver this ordered amount of medication. So again, 420 millunits per hour over the 20,000 millunits, which is in the 1,000 ml. Okay, let's do ratio and proportion. With this, we have done the first two steps needed. Both ratio and proportion and formula, you need to do the steps before you set up your equation. So we've already calculated the dose per hour, and we've also gotten both in the same strength, the available and ordered. So we'll start with our available drug strength, our drug on hand. And that's 20,000 milliunits per ml on the left. And that's going to be equal to our ordered amount, which is per hour, over X ml. So if there's 20,000 milliunits in 1,000 mLs, then 420 milliunits is going to be in how many mLs? And you can see that however many mLs that this ordered amount is in, is going to be how much this patient is going to get per hour. And I just put my little tags over here so that I can see that essentially this is 420 millunits per hour. And it's going to give us the number of mLs per hour that are going to go in. But we have to have our ratio proportion balanced and equal. So the next step, we cross multiply. I like to get x on the left. So I'm going to do 20,000x equals 420 times 1,000. And then that equals 420,000 there on the right. So then I'm going to isolate x. I'm going to divide by 20,000 to isolate x. And then I'm going to, of course, I have to do that to the other side. We have an equal sign. And that gives us 21 mLs. And we know it's per hour. Last, saving the best for last, dimensional analysis. I will do our book setup. You start the same way every time. What do we want to find out? What are the final end labels units? Well, we want to know milliliters per hour. So we're going to start right here. That's our x. X milliliters per hour. It sets us up every time for how to do the first fraction. Because with the first fraction, the upper label is going to match the final top label every single time. What do we have in our problem with milliliters? Aha, we have our drug strength. So we have 1,000 mLs, which contains 20 units. And you have to keep that together. It's not random. Keep it with its buddy. It means something. That's the drug strength. Always just do a multiplication sign, move to the right, and our previous bottom denominator unit or label is going to match the next upper or numerator label. And so we're just going to put units right there. What do we have in our equation that has units? Aha, nothing. It tells us that we needed a conversion right here. And we're going to be going to milliunits. So the units and millunits, what's the conversion? What's the conversion factor? 1 unit is equal to 1,000 milliunits. Let's keep going. Gonna put milliunits up here, no brainer. Milliunits. What do we have? Our order, 7 milliunits. What's with it? It means something. The order is 7 milliunits per minute. So per minute, I can put the 1, I don't have to put the 1, it's the same thing. And how am I doing? Bottom, not there yet. Keep going. So I'm going to put minutes up here. What else do I have to put in our equation? Nothing. There's no data left for that, so I know it's a conversion. We're going to end up with hours. So what is our conversion? There's 60 minutes in an hour. I'm just going to leave out the 1. With dimensional, unlike the other 2 methods, canceling is done before you proceed as a double check. All 3 methods you label, but this one you label and then you cancel, and it's canceling. Anything on the top and the bottom can cancel. So units down here, units up there, milliunits down here, up there, minutes down there, up there. We end up with hour, started with milliliters per hour. That's what we want to be. If you work out that math, it ends up that our X is 21 milliliters per hour. Thank you.